Hello, and welcome to this Vicon training video. Today I will be focusing on using the new series transform feature in conjunction with PX files. This video is a continuation of the Part 1 and 2 videos which demonstrate how to build transform graphs and how to use composite, aggregate, roll-up, and scale nodes. If you haven't watched the other two videos yet, you may want to do so before watching this video. For the purposes of this demonstration, I am using Niagara AX Workbench version 3.7 on my laptop, and I'm running a station on my local machine. In the previous videos, I demonstrated how to create this transform graph. Resolving the graph displays the collection table with all the data from the previous week for each of the 5 histories. The first floor total column is a calculated data value, which is generated by a function on the rollup node. The Resolve Graph menu selection is an easy way to view the results of resolving the transform graph during the engineering phase, but I need to include the results of the graph in a PX view to make it more usable by an average browser user. To do this, I will assign a new PX view to the Energy Data subfolder. In this case, I would rather use a Report PX than a standard PX, so I will change the target media type to Report PX media instead of the default Workbench PX media. The transform graph can be embedded into the PX view by simply dragging it from the nav tree to the PX editor window. Dragging the transform graph to the report pane causes the Make Widget Wizard dialog to be displayed. In the dialog, I need to select the chart item. Notice the graph ord and parameters are displayed. This is the same information that I see when I right-click the graph in the nav tree and select the Resolve Graph item. There is no need to change either the graph ord or parameters in this dialog. The y-axis descriptors are also automatically created for each schema field. For each schema field, the wizard automatically populates the series name and Y column using the schema name. The brush is set as default, which allows the chart widget to automatically assign colors to each line trace. If desired, you could manually configure the brush color or change the pen, which controls the weight of the line in the chart. In the PX editor mode, the chart bindings are not resolved and painted. Toggling out of the edit mode causes the chart to be painted with the traces. The title of the chart header defaults to the slot path of the transform graph in the station. I want to make the title a bit more meaningful. It may also help to turn on the grid lines in the chart canvas. I also want to include the same data in a tabular format in case somebody wants to know the exact values for the records, which might not be easily discernible from the chart, particularly if the report is being exported as a PDF document. Because the report pane lays widgets out in a vertical flow without any spacing, I need to add a label widget to act as a spacer. After adding the label, I need to edit the properties to add a space character for the displayed text. There are other ways to accomplish the same type of spacing, but this is one of the simplest ways. Dragging the same transform graph from the nav tree to the report pane causes the Make Widget Wizard to be displayed again. This time, I'm going to select the Workbench View option. I need to make sure the collection table item is selected and click the OK button to add the widget. Let's take a look at how the report looks now. Now I have the results of the same transform graph being displayed as both a chart and a table in this Report PX file. I think the chart would look better using bars instead of lines, so I'm going to make a quick edit of the PX file to change the chart type. I just need to change the XML tag for the chart from line chart to bar chart. Make sure to change both the opening and closing XML tags. And then save the file. The report looks much better using the bar charts instead of the line charts. This transform graph example and report are very specific and unique to the electrical meters monitoring the first floor tenant spaces. We need to look at a more generic example that can be used with multiple devices, which use a relative PX view. The first floor folder in my station contains subfolders using the AHU X pattern, where X is a sequential device number. These are simply standard folders with simulation logic and a few control points with histories to demonstrate these techniques. These techniques also apply to actual device integration under a driver network. Each AHU subfolder includes a space temp and supply temp control point, each of which also has an enabled history extension. Notice the history IDs include the AHU device name and the point name separated by an underscore character. There is a very basic PX view assigned to each AHU component. Notice the PX view is using relative ords. The same PX view is used by all 20 AHU components in the station. I have a transform graph located under the first floor folder. The source ord for this node is configured to use the AHU1 space temp history, and the second node is configured to use the AHU1 supply temp history. If I were to drag this transform graph to my relative PX view, it would display the chart values for AHU1 on the view for every one of the AHUs. This would obviously be incorrect, and I don't want to have to maintain a unique PX file for each AHU since they have identical point mappings. The source field actually supports using B format, and the B format is resolved when the graph node is resolved. When the transform graph is embedded into a PX view as a chart widget, the B format will be resolved using the component that the PX view is assigned to as the base object. Think of the graph widget as this bound label, with a relative ord of slot colon, and using B format of %displayname%, or possibly %name%. In this case, I can leave most of the text as static text. I will simply replace the AHU1 string with a B format string of %name%. Notice the B format text is blue to differentiate the B format from the static text. Also notice the source schema is now enabled, since the source is not directly referencing a valid history ord. The schema hasn't changed though, so there's no need to edit it. I need to make the same change to the supply temp source node, replacing the static AHU1 string with the same B format string. The B format in the ords for the source nodes is essentially a variable, which will be resolved when the transform graph is resolved in the PX view, and it will be resolved relative to the component the PX view is assigned to. Dragging the transform graph onto the PX view opens the Make Widget wizard. In the wizard dialog, I need to select the chart item. This will embed the chart representation of the transform graph in the PX view. Notice the line chart is using a transform chart binding collection, and the ord uses the transform ORD scheme. The ORD includes the absolute reference to the transform graph that I dragged onto the PX view. It doesn't really matter where the transform graph is located in the station. There is no need to make this ORD relative because each AHU device will use the same transform graph to display its chart. The graph parameter ORD still includes the B format, which isn't resolved until runtime, when the transform graph is resolved to draw the chart lines. Going to the runtime mode shows the chart after the graph has resolved the B format to the actual history source ORDs. The title in the chart header is displaying the slot path of the transform graph used to generate the chart. I need to make that a little bit more meaningful. In this case, I need to add a value binding to the chart header so that I can animate the title. I can add a value binding and use the relative ORD of slot colon. Then I need to animate the title with some B format syntax. Something like %displayname and the static text temperatures should make a suitable title. Notice the chart title now includes the AHU name. The graphic for AHU2 correctly shows the chart title and the histories being displayed are for AHU2 since the B format is now being resolved relative to the AHU2 component. I also want to display the transform graph using a table in the PX view. I cannot use the workbench view of the collection like I did with the energy report because I need to use a widget with an ORD binding that can be used to resolve the B format in the source node ORDs. In this case, I need to use a bound table from the Baja UI palette. A new bound table from the palette doesn't have a binding, so I need to add a transform table binding to the bound table. The ORD field editor doesn't include a picker for the transform ORD scheme, so I will just use the component chooser to select the transform graph that I want to use. Once I have the graph selected, I can manually edit the ORD to change it to the transform scheme. I do this by replacing the station colon and pipe symbol with transform colon. Next, I need to specify the graph ORD for the query property. Notice after I select the graph ORD, the graph parameters are automatically populated, and there should be no need to edit the values. The bound table is now resolving the transform graph and the B format in the source nodes to properly display the history data for this AHU. Transform graphs serve as templates to define data sources and to configure graph nodes, which manipulate the data for reporting purposes. The data manipulation includes combining data sources into a single data set using the composite node, and applying functions to the data using aggregate, rollup, and scale nodes. The data sources are histories and can be referenced by the actual history ORD, or they can leverage B format syntax, which is resolved against the base component of the PX view when the chart or table widget is displayed. Using the B format syntax in the source ORD property allows a single transform graph to be used in a relative PX view, which may be assigned to any number of identical devices in the station. This provides robust reporting capabilities while minimizing the required engineering effort. Thank you for taking the time to watch this video, and stay tuned for additional Vicon training videos on other new features and changes in the Niagara AX framework.